All right, so now we're on to the last video of section 6.3 using elimination. All right, and the first video we did was just when it was already set up for us to use elimination, or when we only had to multiply one equation to solve. Well, in video 2, this video, we are going to now continue elimination, but you'll have to multiply both of the equations in order for you to solve. All right, so it won't just be as easy as the other ones, but it's still the same thought process. You're still trying to see, well, what do I need to do in order to have the same x value that is positive or negative, or the same y value that's positive or negative? All right, it's the same thought process as sometimes you'll have to multiply both equations. So let's go ahead and do a problem. So it's, what is the solution using elimination? All right, so now we have 3x plus 2y is equal to 1, and we have 4x plus 3y is equal to negative 2. All right, so this isn't set up where we have a y and an x or a y value that have the same number but different signs, and it's not set up that all we need to do is multiply 1 by 3 like we did with the 15y and negative 5y. In fact, none of our numbers are even opposite signs. They're all positive, so that means we're going to eventually have to multiply by negative. And then we just pick one of our variables. So we see what is easier for us to multiply into. 3 and 4, their first common multiple that they share is 12. 3 goes into 12 4 times, 4 goes into 12 3 times, and there's no other number lower than that they share. 2 and 3, their first common multiple that they share is 6. 2 goes into 6 3 times, 3 goes into 6 2 times, and that's the first number that they share. Since 6 is smaller than 12, I'm going to go ahead and pick the y values for me to eliminate. All right, so what that means is we need to multiply each of these y's to get to that common number 6. So I need to multiply 2y by 3 to get to 6y, and then I need to multiply 3y by 2 to get to 6y. But now if we only multiply by 3 and 2, we know that this is going to not allow us to use elimination like we've been doing so far, because they'll both still be positive. So you just need to make one of them negative. It really doesn't matter which one. I'm just going to go ahead and say negative 3. Then we distribute the negative 3 in, and every number gets multiplied just like before. So it's negative 9x minus 6y is equal to negative 3. Then we distribute the 2 in. So it's 8x plus 6y is equal to negative 4. Now that we have the same y but different signs, we can go ahead and add down. So this will then give us negative x, the y's eliminate, is equal to negative 7. We would then divide each side by negative 1, and we get x is equal to 7. Once we solve for that, we then just need to plug 7 into any of the equations for x. I'm just going to pick this one since it's my smallest y value, so after I substitute in, it'll just be easier for me to divide by 2. Not that it's hard to divide by 3, but whichever one you prefer. So it's 3 times x plus 2y is equal to 1. 3 times 7, since we know that x is equal to 7, plus 2y is equal to 1. 21 plus 2y is equal to 1. Subtract 21 from both sides. So then we get 2y is then equal to negative 20. Divide each side by 2. And y is then equal to negative 10. So that means our solution for this is x is 7 and y is negative 10. That is the only point that will satisfy both at the same time. And you can plug them back in to check to make sure it works. All right, so now in substitution, we learned that if we got as an answer of 2 is equal to 2, then we knew that this was infinitely many solutions because it was a true statement. And that holds true for elimination as well. So if we get a true statement, then we know it's infinitely many. And then if we got something that says 0 is equal to 4, we know that that is a false statement, so this is no solution. So none of that, or all of that, still holds true even though we're using elimination, right? So we still are looking for these special cases where we might get a true or false identity. All right, so now we're going to go ahead and do a problem using this. So we have this system of equations. We have 2x plus 6y is equal to 18. And then we have x plus 3y is equal to 9. All right, so I have here where x is 1, so I can quickly and easily get to the opposite sign of 2x by multiplying just by negative 2. So I'm going to multiply everything here by negative 2. All right, so my first one I had was 2x plus 6y is equal to 18. And then when I distribute the negative 2 in, I get negative 2x minus 6y is equal to negative 18. So now I'm going to add down. Now, when we add down, the x's eliminate and the y's eliminate. So that means I have 0 left on this side, and 18 plus negative 18 eliminates as well. So I'm left with 0 is equal to 0. So this is a true statement. True statement. So this means that the answer is infinitely many. All right, when you use elimination, the true statement that you will get is this 0 is equal to 0. If you get a false statement, to know that it is no solutions, you will get 0 is equal to some other number. That will be false. All right, so that is the last question that we're going to do together. And then the last thing is just going through a quick review. All right, so when you're using elimination, you can use this flow chart to help you decide if there's something else that you need to do. So the first question you can ask yourself is, can I eliminate a variable by adding or subtracting given the given equations? Now remember, we didn't go over subtracting. If one of your other teachers did it, by all means, you can subtract down, but we're only going to do adding because I noticed that when you subtract down, there seems to be more room for error. A little bit more times I see people are making simple mistakes using subtraction. So we're only going to add down. But can you do that right away? And if you can, just go ahead and do so, and then you're finished. If not, then you ask yourself, can I multiply only one of the equations in order to get the same number but different signs so I can add or subtract down? But remember, we didn't go over subtracting, so we're not going to ever do that. But so we can add down. If yes, then you're done. If no, then you need to multiply both of the equations by different numbers, and then you will add down. All right, and then you're done. So this is what you can ask yourself in order to use elimination. And that is it for this video, and that is it for this section.